This video is going to walk you through two implementations of a program that converts a packed BCD number to its binary equivalent. So the first implementation is pretty straightforward. We unpack the two BCD numbers to have the digits into separate registers, and once we have it, we compute the value of this expression, and that's the result. So I assume that the number to be that the packed BCD number is stored at the memory location 102 for age. I load that packed BCD number into the B register. In order to get the lower nibble, I copy the B register into the accumulator, then mask off the higher nibble and store this value in the E register. So the E register now holds the lower nibble of the packed BCD number, which is the ones digit. In order to get the higher nibble, I copy the original packed BCD number in the accumulator again, and I mask off the lower nibble and then right shift this value 4 times. So at this point in the program, I have the higher nibble of the packed BCD number in the accumulator, and if it happens to be 0, all I need to do is add E to the accumulator, and that's the result. If that's not the case and the higher nibble is non-zero, then I need to have 10 times the higher nibble and then add this value to the lower nibble. So in order to do this, I have a loop that adds 10 to the accumulator as many number of times as is the value of D, and the accumulator is initially 0. So at this point in the program, I have 10 times the higher nibble in the accumulator, and I add the lower nibble to this value, and that's the result, and I store it in the memory location pointed by M. So that's it. So now let's move on to the other implementation, and I have it here. In this implementation, what we do is this. The packed BCD number is represented as HL. H is the higher nibble and L is the lower nibble. The value that we have in the packed BCD number is H times 2 to the 4 plus L. Right? That's how binary number system works. And the value that we want is H times 10 plus L. So as you can see, how we achieve this is by subtracting 6 times the higher nibble from the packed BCD number, right? If we subtract 6 times H from the packed BCD number, what we'll be left with is this value, and that's exactly what we want, right? So and the multiplication by 6, multiplication of the higher nibble with 6 can be broken down into multiplication with 4 and multiplication with 2 and their sum, and these two multiplications can be achieved by shifting bits right and left. Okay. So once again, I assume that the packed BCD number is stored in the memory location 102 for age. I make a copy of that packed BCD number in the B register. Then in order to get the higher nibble, I copy the contents of the B register in the accumulator. Then I mask off the lower nibble and right shift this value 2 times. So when I right shift this value 2 times, I have 4 times the higher nibble, right? 4 times the higher nibble, and I stored this value in the D register. So now in the D register, I have 4 times the higher nibble. In order to get 2 times the higher nibble, all I need to do is right shift the value that I have now in the accumulator once, right? Once. Okay. And now, since we have 2 times the higher nibble and 4 times the higher nibble in the accumulator and the D register respectively, adding D to the accumulator causes the accumulator to have 6 times the higher nibble, right? So 6 times the higher nibble is now stored in the D register. All I need to do is subtract 6 times the higher nibble, that is the contents of the D register, from the original packed BCD number. So I copy the original packed BCD number in the accumulator and subtract the contents of the D register from the original packed BCD number, which in effect subtracts the original packed BCD number, subtracts 6 times the higher number of the original packed BCD number from the packed BCD number itself, and I have the result in the accumulator, and I copy that result to the memory location pointed by M. That's it.